Two small identical positively charged spheres A and B are suspended from the ceiling at point C by non-conducting threads as shown below. Question 5.1.1, draw a labeled closed vector triangle showing all of the forces acting on sphere A. Include two angles in the triangle. So they tell us that both A and B are positively charged. That means A is going to be repelled to the left because of the electrostatic force. It's also connected to a rope or some thread, and so there's going to be a tension force. And lastly, it has some mass, so there's going to be a force of gravity. Now we can take these three forces and draw a triangle. We can draw it like so. So the force of gravity points down, the electrostatic force points to the left, and the tension force then completes that triangle. Now they do ask us to include two angles, so we know that that's going to be 90 degrees. If we look at the angle that the tension force makes with the horizontal, that's 60 degrees. And so we look here, this is our tension force, and the angle it makes to the horizontal must be 60 degrees. Then because of some angles in a triangle being 180, this must be 30 degrees. Question 5.1.2 says, if the mass of each sphere is 1.5 grams, calculate the magnitude of the electrostatic force acting on A. So they've given us the mass, so of course we should start with the force of gravity, Fg. We can say that Fg is equal to mass times 9,8. The mass is 1.5, so 1.5 divided by 1,000, because it must be in kilograms, multiplied by 9,8, and that gives us 1,47 times 10 to the negative 2 newtons. Now from here, we can use trigonometry to work out the electrostatic force. If we're using 60 as our reference angle, we have the opposite side and we want the adjacent side, we can use tan. So we can say tan of 60 degrees is equal to Fg divided by Fe. Since we want Fe, let's switch. So Fe is going to be Fg, which is 1,47 times 10 to the negative 2 divided by tan of 60 degrees. That then gives us an answer of 8,49 times 10 to the negative 3 newtons. 5.1.3 reads, calculate the magnitude of the electric field at A due to B if the charge on the sphere is 4,8 nanocoulombs. So 5.1.3, we can use the equation E, which is the electric field, is equal to F, which is the force, divided by Q, which is the charge. So the force is 8,49 times 10 to the negative 3 divided by the charge, which they've given us as 4,8 times 10 to the negative 9. Remember, nano, N, is times 10 to the negative 9. We then get the electric field to be 1,74 times 10 to the minus 6 Newton Coulomb. Okay, let's move on to question 5.2. A square coil with sides of length 0.25 meters contains 200 turns. So I'm just going to make little notes here. So N is 200. And is positioned perpendicular to a uniform magnetic field of magnitude 0.75 T. So it's something like this. There's my magnetic field, 0.75 T. That's the B value. The coil is then quickly pulled from the field in 0.2 seconds. So delta T is 0.2. Moving perpendicular to the magnetic field to a region where there is no magnetic field. 5.2.2 says calculate the EMF induced across the coil. So the equation that we're going to use is EMF is equal to minus N delta phi divided by delta T. We know N, we know T, we don't know delta phi. So delta phi is equal to, well, the final minus the initial. They tell us that it is moved to a region where there is no magnetic field. So if we just look at the final phi, so final here, it's equal to BA cos theta. If there's no magnetic field, it means that the phi, well, the final phi is going to be 0. So we can then calculate the initial to then get the delta. So the initial is going to be B, which is 0.75. The area of a square is side squared. So the side is 0.25 and that's squared. And now cos. And what is the angle? So when we're looking at the angle, we must focus on the normal of the coil to the magnetic field. The normal of the coil and the magnetic field are on the same plane, so the angle is 0. And so we'll have a solution here. Now we can calculate the delta phi. We can say that the delta phi is going to equal 0 minus 0.75 times 0.25 all squared, and cos of 0 is 1. So 0.75 times 0.25 squared is 0.05. So the delta phi is 0.05, or minus 0.05. Now we can substitute and solve. So minus N is 200. My delta phi is minus 0.05. And that's divided by 0.02 rather. And that then gives us an EMF of 46, multiply minus 200 divided by 0.2. That's 46.9 volts.